Is there anyone here who remembers the Flexbox revolution in CSS? How the world of layout has changed then. And what if I told you that CSS is on the verge of an update that will surpass even Flexbox? Soon, you will find out what it is. But first, Hemingway's stories are capable of touching anyone's heart. A new CSS property has been released. Frontier is thrilled, Frontier goes to "Can I use?" Frontier waits for 5 years. Very soon, the story will lose its relevance because the genie of Houdini CSS is about to come out of the lamp. Well, like Houdini, we've been waiting for about 5 years now. But let's get it right. Houdini CSS is a set of browser APIs that allows developers to extend CSS, use JavaScript, affect CSS rendering, and tell the browser how styles should be applied. Houdini's implementation can be seen at "Is Houdini ready yet?" At first glance, it seems, well, not a damn thing is ready yet. But in fact, the first 3 APIs are already on the threshold. The fact is that they are the most desirable. Even Safari was left to implement only the Paint API. Yes, Mozilla stands out with the minus sign, but Chanterelle as a whole barely shows signs of life. Of course, I would like to get the Layout API. Unfortunately, it will have to wait. The other APIs are somewhat less desirable. Based on their readiness, we conclude that in the near future, we will be able to use 3 out of the 4 main APIs in production. If you're building, for example, an admin panel and you only need Chrome, you can already use Houdini CSS cautiously. And now let's dive into why this is a revolutionary update. Let's remember how our browser remembers HTML. This is a stage where the sizes and positions of elements on the page are determined. There is a painting stage when the visual components of an element, such as background color or borders, are drawn. You may have noticed a couple of APIs called the Paint API and Layout API. These APIs are considered high level as they allow for the expansion of CSS capabilities during the painting and layout stages, respectively. Animation API is also a high-level API that enhances CSS in the process of animating elements. The other Houdini APIs are considered low-level and serve as the foundation for the higher-level ones. Let's imagine that a new property has been added to CSS that allows us to apply a chessboard background color to elements, and we would like to polyfill this property. Let's give it a try. Since we need to paint something, we should turn to the Paint API. Write Paint checkboard for the element's background. This is an unprecedented construction in CSS. Paint is some kind of function, and we can assume that it provides us access to the element during the rendering stage. So what is the checkboard? It's a substance called a worklet. Each top-level API corresponds to a worklet. A worklet is a JavaScript script that runs during rendering. Interestingly, the execution of these scripts is independent of the main JS thread. They can even run in parallel across multiple threads. So to create a polyfill for a chessboard, we need to write a worklet. Here's how it works. It's a regular class with a paint method. The paint method takes a context, which is a regular canvas object. It also receives the geometry of the element to which the worklet is applied and some parameters as well. Now, nothing prevents us from tiling the area of the element with small squares, as if we were working with a regular canvas. We've written the worklet, but the browser doesn't know about it yet. Need to tell the browser about it. Register the worklet under the name checkboard. Also, we need to add the file with the worklet to Paint worklet. As you might have guessed, worklets can come from anywhere. For example, through a CDN, or simply as a package downloaded via NPM. That's it. Now we can include our worklet wherever we want and enjoy the chessboard grid. But what if we want to parameterize the rendering? For example, increase the distance between the squares. This can be done using CSS variables. For example, we added a couple of variables for the distance between the cells and the size of the cells themselves. In the worklet, we need to implement static getter input properties and list the variable names. And now, in the Paint function, we can retrieve their values and use them in calculations. Now everything works. We can even update the variable values and everything will be redrawn. Now let me give you a real example. Who needs chess-like CSS properties anyway? CSS now has the ability to create multicolored borders for elements. Let's say this feature was introduced 4 years ago, but browsers haven't implemented it yet. However, you can now write a worklet and achieve the multicolored border effect before it's implemented in all browsers. You can familiarize yourself with the worklet code separately. It's a bit more complex, but overall understandable. Polyfills are certainly great. Now we can quickly get new features. But the revolutionary aspect of Houdini CSS is not even about that. We now have unlimited power over the browser. What we used to do with components, sets of CSS, classes, or mixins can now be solved with just a couple of lines of CSS. If we want to display a QR code for any text, no problem. Before, we had to come up with some components. Now, we just need to render a worklet and add a parameter with the text. Furthermore, we can change the appearance of checkboxes using pure CSS, without the classic method of hiding the native checkbox and creating a new square. We can even write JavaScript in CSS and call it a worklet using CSS variables. Just think about it. Writing JavaScript in CSS. Dear Lord, I hope I never encounter that in real life. And we are only talking about the Paint API here. There's also the Layout API. With that, we can enhance the capabilities of CSS in determining the size and layout of elements. With it, we could create polyfills for Flexbox or Grid, for example. But let's say we have a task at hand. The designers want you to create a masonry grid. This is when elements are arranged one after another without creating empty spaces, even with varying heights. If anyone has ever done this, they know it can be a major headache. However, now we can simply use the layout function with the worklet masonry. We can also add a couple of parameters, and of course, include the worklet file. All that's left is to register the worklet, where the magic of masonry happens in the layout method. If you're interested, you can delve into the calculations. Animation can now be created using Animation API. Although, to be honest, tasks related to front-end animation are quite rare. The current capabilities of CSS are more than sufficient. Well, we've looked at the high-level API. Now let's understand the purpose of the low-level API. For example, the Properties and Values API. It's quite simple. The API allows us to extend CSS variables, defines the type, initial value, and inheritability. We can initialize variables either in JavaScript or directly in CSS. I think it's obvious that the API can work in conjunction with worklets, defining the initial configuration of parameters. There is also the Typed Object Model API. Previously, when we needed to modify something in CSS through JavaScript, we had to concatenate and convert values into strings. The Typed Object Model allows us to work with CSS in a more familiar way by representing style values as objects. From now on, we can invoke the Computed Style Map method on an element and obtain a typed object. Additionally, we can set inline styles through attribute style map and specify the value in them, for example. It is important to note that Computed Style Map returns computed values from the style sheet, not the inline values, so nothing has changed in this regard. To obtain the inline style, we can use getOnAttributeStyleMap. Apart from get and set, the API includes several other methods for working with styles. The typed object model of styles can be useful both in worklets and when working with DOM elements. Some words about the unreleased APIs. The Parser API allows us to access the hidden syntax analyzer of the engine that parses CSS styles. With that, we can create full-fledged CSS polyfills without the need for a worklet layer. And as you might have guessed, the Fonts API provides methods for measuring the dimensions of text elements displayed on the screen. It allows developers to influence the rendering of characters, such as controlling capital letters in text. Now, you probably understand how revolutionary the Houdini CSS development is, but let's take a critical look at it nonetheless. The front end in our case already lacks hygiene flexibility, and adding Houdini CSS to some projects will introduce another dozen lines of code in the package JSON. This is not very good from a security standpoint. As you may have noticed, polyfills through worklets don't look very native. It would be nice to create full-fledged CSS properties according to the specification and have them applied without the need for a polyfill when they are implemented in the browser. I hope the Parser API will address this situation. There are also assumptions that abuses in worklets, especially for printing layout, will slow down the rendering of an application. For now, it's difficult to assess the validity of this hypothesis. In any case, please, write a comment with your thoughts on the matter, and don't forget to subscribe and like the video, and I will continue to make interesting videos for you. Hugs to everyone. Bye!